Hey there, Mr. Sutton here with the AB Calculus Chapter 3, Quiz 4, Extra Practice Number 2 solutions on derivatives of transcendental functions. To take the derivative of this one, we're going to need the product rule. That's u prime v plus uv prime. And I'll set up a box and ribbon to help us with that. So we have our factors, tan of x and arctan of x, and their derivatives, which are secant squared of x and 1 over x squared plus 1. Using the ribbon to multiply this out, we've got secant squared times arctan of x, that's u prime v, plus uv prime, that's going to be tan of x times 1 over x squared plus 1. For this derivative, we're going to need the quotient rule, that's u prime v minus uv prime over v squared. So it's box and ribbon time for this one. I have my numerator, x cubed plus 6x, and my denominator, 1 plus sine squared of x. Derivatives of those, this is going to be 3x squared plus 6. And over here, we're going to need the, let's see here, this is going to be the chain rule. So we're going to have 2 times the sine of x times the derivative of sine, which is cosine. And now we're going to put it all together with our quotient rule. So using the ribbon, we've got 3x squared plus 6 times 1 plus sine squared of x. So that's u prime v minus, so we'll do the other half of the ribbon here, parentheses x cubed plus 6x times 2 sine of x cosine of x, all over v squared, so 1 plus sine squared of x quantity squared. Before I take a derivative on this one, I'm first going to simplify this using log rules. This stuff inside here is really secant of 3x, all of it raised to the third power. Since that's inside this ln, I can pop this exponent of 3 out in front. So this is really 3 ln secant of 3x. And now I'm going to use the chain rule. So on the outside, I've got 3 ln of something. Well, the derivative of that is going to be 3 over the something. So 3 over secant of 3x in this case. Next, I have to take the derivative of secant of 3x. This is another chain rule. We have secant of something. Derivative of that is going to be secant of something tan of something. The something being 3x this time around. And then finally, we multiply by the derivative of 3x itself, the innermost function, giving us 3. To find this derivative, since I have variables in both the base and the exponent, I have to use logarithmic differentiation. So I'll start by taking the ln of both sides. So that's ln of y on the left. On the right, the exponent pops out. We have 5 sine of x times the ln of the base here, so ln of x. Next, let me implicitly differentiate. So we've got 1 over y on the left, dy over dx, because y is an inner function of x in this case. On the right side, I need the product rule, so let me set up the box and ribbon. I've got factors of 5 sine x and ln of x. 5 sine derivative is going to be 5 times cosine of x. For the derivative of ln of x, we've got 1 over something, so 1 over ln of x, times the derivative of ln of x using the chain rule here. So we've got 1 over x. And then multiplying this out using the ribbon, we've got 5 cosine of x ln of x. That's u prime v. And there plus uv prime, we've got, let's see, if we multiply all this together, this is going to be 5 sine of x over x ln of x, if we just combine that a little bit. Still have to isolate dy over dx. I can do that by multiplying both sides by y. So I've got all the stuff on the right side with a y outside, and we have a big parentheses going on here. And then since this needs to be, generally speaking, in terms of x, we don't want y hanging around. I guess it depends on the instructions. These instructions didn't explicitly say we wanted the answer in terms of x, but if we did, we could substitute ln of x to the 5 sine of x for the y right here and get it entirely in terms of x. On this problem, to take the derivative, it's looking initially like we're going to have a whole bunch of chain rules and a big product rule. However, this cotan squared x minus cosecant squared of x expression can actually be simplified a little bit. You might remember the identity 1 plus cotan squared equals cosecant squared. Well, that means that cosecant or cotan squared minus cosecant squared has a value of -1. So this whole thing in here, we can just replace that with -1. Negative 1 cubed is just negative 1. So this is really negative x to the fourth. And now the derivative of negative x to the fourth, because we actually haven't taken a derivative yet, that's going to be negative 4x cubed. For this problem, we're trying to take the derivative of this exponential expression. So this is a chain rule. Our outer function is 1989 to the something. So the derivative of that is going to be 1989 to the something times the ln of 1989, ln of the base. But now we have to take the derivative of 1997 to the x. So that's going to be 1997 to the x times ln of 1997. And there we are. On this problem, we can make our life a little bit easier if we simplify this expression inside the parentheses using log rules. We know that ln and e cancel each other out, so we can rewrite this whole thing as really just arcsecant of 5x plus 2. And we still have a chain rule to deal with, but it's less of a nasty chain rule than we had before. So we've got arcsecant of something. Derivative of that is going to be 1 over the absolute value of something times square root of something squared minus 1. So in this case, that's 1 over absolute value of 5x plus 2 times 5x plus 2 squared minus 1 inside a square root here. And then we have to multiply by the derivative of the something, which in this case, the derivative of 5x plus 2 is just going to be 5, so we'll just stick that on top here. To take the derivative of this function, we're going to need to use the product rule, u prime v plus uv prime. So I'll set up the box and ribbon to help organize that. We have our factors, x squared minus 4 to the third power, and 2 minus 7x all raised to the fourth. Derivatives of those, these are both going to require the chain rule. So up here we have something to the third. Derivative of that is 3 times something squared, the something being x squared minus 4. Now we have to multiply by the derivative of x squared minus 4, which is 2x. Over here, we've got something to the fourth power. Derivative of that is going to be 4 times the something to the third. And then we still have to multiply by the derivative of the inner function, which is negative 7. All right, putting it all together, we've got all the stuff in the lower left times 2 minus 7x to the fourth. And then we have all the stuff in the upper left times all the stuff in the lower right, like so. And there we are. For taking the derivative on this one, I'm first going to rewrite these with exponents. So this is 5 times parentheses 2 plus parentheses 3x to the 1/2, all of that raised to the 1/2. So a couple nested 1/2 powers going on. And now I can use the power rule along with the chain rule. So for my outer function, I've really got 5 times something to the 1/2. Derivative of that is going to be 5/2 times something to the negative 1/2. The something being the 2 plus 3x to the 1/2 in there. Now I have to multiply by the derivative of this inner function. So that 2 gets differentiated away to 0. We really just have the 3x to the 1/2 to worry about. Derivative of that is going to be 1/2 times 3x to the negative 1/2 times the derivative of 3x, which is a little tail out here of 3. For the derivative on this one, since y is pretty much impossible to isolate, I'm going to use implicit differentiation, treating y as an inner function of x anytime I take its derivative. So going from left to right, we've got derivative of 3y. That's going to be 3 times dy over dx, because again, anytime I take the derivative of y, I have to multiply it by the derivative of y, because it's an inner function. Here, this 6x is just going to become 6. And over here, this is going to be 21y squared dy over dx. At this point, I'm going to get all the dy over dx's on one side and everything else on the other side. So 3 dy over dx can stay on the left. We're going to subtract 21y squared dy over dx to get it over there as well. And then I'll subtract the 6 to get it to the other side. And at this point, I can factor out a dy over dx, leaving me with 3 minus 21y squared. And now to isolate dy over dx, I just divide both sides by that parentheses. So we have negative 6 over all that stuff is going to give us dy over dx. For this problem, I'm trying to take the derivative of this crazy expression. So I'm going to have to use a couple chain rules on this one. My outer function, I have sine of something. Derivative of that is going to be cosine of the something. So cosine of 3e to the 5 tan x. Next, my next function in, I've got 3 times e to the something. Derivative of that is going to be 3 times e to the same something. Now I have to multiply by the next function in, which is 5 tan of x. That's going to be, derivative of that's going to be 5 secant squared of x. And we're done.